Okay, all right. So here we are, Tuesday morning, first period after the snow day. So here I am, and the class that's supposed to be here right now is in the computer lab. So I figure I try to sneak one in and shoot all these videos and get it over with. Okay, all right. So page 91, have a 39 to 42. Okay, now right off the bat, you might very well be staring at this and have no idea what you're doing. Okay. No, I don't blame you. All right. It's not the most intuitive questions. So what I'm gonna do is I'm gonna do all four, and there's a reason why I assigned four questions because I knew that it might very well stump you guys a little bit. Okay. All right. Now, some of you might be looking at this and say, well, look, there are no numbers, so what am I solving for? And so with that, you need to look at the directions. It says solve for x, meaning the end game is the same like all the questions we solve. You still want x at the end. Okay, that's what you're going for. So what do you do, right? So that's the question. Now, what you need to do is actually you need to pretend a and b are just regular numbers. So let's do that on the aside. Let's say that's 1 and that's 2. Okay, keep it simple. Now, how will you solve for x? Yeah, you would add 1 on both sides. Right, these cancels out, and then you have 3. So if you use that as an example, and you look at this, you would say, well, you know what? To solve for x, I'm just going to add a. And per usual, this cancels out. I'm left with just x. Here I got b plus a, and that's what it is. Okay, now you write a plus b because it's commutative, but doesn't really matter. So b plus a, that's the answer. Okay, now for some of you, this one might not be a very satisfactory answer. But this is all we can do given the fact that there are no numbers. Okay, so solve for x. Okay, we got x, b plus a. That's what x is. Okay, all right, now having said that, look at 40. Let's see, a plus x equals b now. I like this one. Here, you're gonna look at this. Now, you can think about it O-Manning style, which is, what does O-Manning want? O-Manning wants the x in the front. So it's x plus a equals b. Okay, now, here we're gonna subtract a on both sides. So these cancels out. And then we got b minus a on the other side. All right, not a minus b. Not the same thing, all right? B minus a has to be that way. All right, next, 41. Ax equals b now. I mean, I think you see where they're going with this. They're going through all four operations, okay? And I think that's good for a 6th grader, all right? Even for a 7th grader, I think this is good. Now, here you got ax. What does that mean? Yeah, a times x. So what's the opposite of multiplication? That's right, division. So imagine this to be like 3x equals 9. Think about it like that. Right, you divide both sides by 3. In other words, you divide both sides by a. If these were to cancel out, then so would these, right? A over a is 1. All right, it doesn't matter. You don't even know what kind of number that is. Anything over itself is 1. And then x is, yeah, look at this. Just as it's 9 over 3, now 9 over 3 is 3. So here the answer is 3, but b over a is just b over a. Okay, because we don't know what the numbers are. Okay, now let's try one last one together. Now, at this point, you want to pause and actually try to do 42 or, the last one, then that's good, It's not bad. It's not bad. Now, this last one is division, right? So you do the opposite. So what do? You multiply, right? You could do A over 1, doesn't matter. So these cancels out, left with X. BA, right? B times A is BA. Or AB. That's technically more acceptable because you want it alphabetically. So if it's C times B times A, that's just ABC. Okay, so that's it. All right, we finished these 4. Hopefully it wasn't too tough for you. And okay, thanks for watching. Have a good one.
OMG, that was so good.